Hello, everyone. My name is Shivani Gupta. I'm a Director of Product Management at Couchbase. Welcome to Couchbase Connect 2021. In this session, I will be talking about application modeling and deployment patterns with scopes and collections. Scopes and collections is a new feature that we introduced in Couchbase Server 7. So I'll begin by giving you a quick overview of this functionality. For more details, you can look into our public documentation as well as listen to many other sessions in Couchbase Connect 2021. The focus of this presentation is to talk about three use cases which are experienced by many application developers and how you can apply this functionality of scopes and collections to these three use cases. The first is migrating from RDBMS to Couchbase. The second is mapping a microservices-based architecture to Couchbase. And the third is how you would map a software as a service multi-tenant application. Scopes and collections essentially provide multi-level data containment. So they are logical containers inside a Couchbase bucket. And as I said, these are introduced in Couchbase Server 7. For those of you who are familiar with Couchbase, you would know that once you create a Couchbase cluster, you create one or more buckets inside it to start storing your data, which is JSON documents. So prior to 7.0, you would essentially create a bucket and then straight away start storing documents. But now you have two additional levels. Within a bucket, you can have one or more scopes. And within each scope, you can have one or more collections. We have a cluster limit of 30 buckets per cluster. For scopes and collections, this is a couple of order of magnitudes higher. So it provides for much higher levels of scale. So you can have up to 1,000 scopes per cluster, and you can have up to 1,000 collections per cluster. So it's up to you and your architecture how you want to slice and dice the collections and scopes. You can create one scope with 1,000 collections. You can you can create 10 scopes with 100 collections each, or you can create 1,000 scopes with one collection each. So you can, use these as it works best for your application. Scopes and collections provide lifecycle management and access control at multiple levels. So this is the big capability which makes it an essential tool for all these three use cases that we're going to talk about. So now you get lifecycle management and access control at bucket level, scope level, and collection level. So the namespace is independent at each of these levels. So what this means is that two documents in different collections can have the same key without a namespace conflict. Similarly, two collections in two different scopes can have the same name without a namespace conflict. So also two scopes in two different buckets can have the same name without any namespace conflict. You can also index each collection individually as is required by the querying patterns for that specific collection. In terms of lifecycle, you can create, drop, as well as set expiration, which we call as TTL/time to live on each collection separately. You can also monitor statistics on each collection. So we have operation level stats, basically how many operations per second are being performed on each collection. We have memory usage per collection as well as disk space utilization per collection. So this helps you monitor statistics on each collection. Security control at individual collection level is the big thing which will enable the patterns that we are going to talk about in the slides coming up soon. So you can set security at individual collection level, scope level, or bucket level using role-based access control. We have out-of-box roles available to provide read access, write access, index creation, all sorts of different things that one would perform can be managed at any of these levels, bucket, scope, or collection level. XDCR, which is our cross data center application, can also be set up at any of these levels. So you can set up replication between two clusters at collection level, or at a scope level, which would include all the collections underneath, or at a bucket level. And while doing so, you can also take advantage of remapping the source to a different destination name, or set up filtering. These are very useful, especially in migration scenarios from a pre-Couchbase 7 cluster to a Couchbase 7 cluster, which uses scopes and collections. Same thing with backup restore. You can take a backup at a bucket level, but restore individual collections, or you can just back up individual collection and restore it with a different name, or you can even filter some data while restoring. So there is a lot of flexibility available with both backup and restore, as well as XDCR. So let's look at our first use case, which is how you would migrate an RDBMS application to Couchbase. This is something a lot of you might be considering as your RDBMS application hits scale limits, or you're running into the issues with the rigidity of the relational schema model, and you would like a more flexible JSON model. So what you can do with scopes and collections is you can retain your RDBMS data organization while enjoying a flexible JSON schema. Also, you can write simple queries using a query language, which goes as NCL, which are almost SQL-like. So it will be very familiar to developers from the relational world. So here are the relational modeling data modeling equivalents. A Couchbase cluster is one or more servers, since we are a scale-out distributed architecture. So it's the equivalent of a server in the relational world. In Couchbase, once you create a cluster, you create one or more buckets inside it. Just like in a relational database, you would create one or more databases on your server. Then relational databases, or at least some of them, have something called schema, which is essentially a collection of, is a grouping of tables as well as other derived artifacts belonging to the table. So it's a little bit of a misnomer, because this word schema here does not really mean schema as in the sense of structure of data stored. So what is called schema in the relational world is equivalent to scope in the Couchbase model now. A collection in our model is essentially like a table in the relational model, but with a flexible schema, because in Couchbase, you would store JSON documents or binary documents inside a collection, whereas in a relational world, you store neatly structured, predefined rows in a table. So you get the entire hierarchy that you would be used to in a relational model, but with the flexibility of the document model. So when you're migrating or re-architecting your relational application for a NoSQL world, you would typically not have as many tables, as many collections as you have tables, because the JSON document is inherently closer to object-oriented mapping for your applications. So you want to take advantage of that. You do not want to keep the same level of denormalization that you have in your relational model. So you would want to, so same level of normalization that you have in your relational model, sorry. So you would want to denormalize to some extent. So, you would combine some tables together into a single collections. So which means if you had 100 tables in your relational model, you may end up with fewer tables, say 20 tables in Couchbase, 20 collections in Couchbase. So here's an example of how one might use these entities. This is actually a travel sample data set that comes with our sample data set. So once you deploy a sample data set, you can play with this data. It gets deployed in a bucket called travel sample, and it stores various travel assets in a scope called inventory scope. So it has 4 different collections, at least, to store airline assets, airports, hotel assets, routes between airlines. There is also a default scope always. So if you do not want to create a scope, you don't have to. You can just start creating collections inside the default scope. So let's look at how you might work with the example we just looked at, the travel sample example that we just looked at here. So I'm going to walk you through some queries working with the data in this sample. So first thing we do is set the query context to the bucket and scope name. What this does is this tells the query workbench, or you can do it even in any of our SDKs using the APIs of the SDK. What this does is it sets the context, and then any collection you use is within that namespace. So you don't have to keep repeating bucket.scope.collection name. And this makes the statements a lot more readable and intuitive to write. So after I've set the query context, what I'm doing is inserting a few documents into the airport collection. So I'm inserting 2 airports in 2 different cities. Then I'm inserting a route between those 2 cities in the route collection. Next, I create a couple of indexes on each of these collections. And as you can see, both these insert and create index statements are very simple, very much like what you would do in a SQL-based application. Next, what I want to do is I want to write a query which finds all the cities that have incoming flights from the city of Toulouse. So this would require a join between the airport collection and the route collection. So as you can see, the query looks very much like what you would write as a SQL developer on a relational database. So once you've modeled your data using collections inside Couchbase, it becomes much easier for you to bring your existing SQL skills to Couchbase and get productive quickly. So with that, let's look at our next use case, which is how you can map a microservices-based application using these constructs. So microservices is a very popular architectural pattern these days because it makes it much easier for application development to be agile, and it helps building applications which are loosely coupled and can be scaled and built faster and deployed faster. So that is why microservices need loose coupling. So that each of these pieces can be developed and deployed independently. And with scopes and collections, since each of them has independent lifecycle management, they provide a good alternative to buckets for deploying your microservices. Also, one of the things required by microservices is that each microservices data should be private to it and should be accessible only via the APIs of that microservice. Again, with our role-based access control, which is role-based access control available at individual collection level, collections become a very viable choice for mapping the data store of each microservice. And since, as we saw, you can have up to 1,000 collections in a cluster, collections provide a highly scalable choice for mapping microservices. So it allows for higher application density and consolidation opportunities. So this is an old pattern. So prior to Couchbase Server 7, before we introduced this feature, This is what many of you might have been doing or would have had to consider doing, is basically use a bucket per microservice. So this is a simple example that is shown here. It's a CRM kind of application deployed in a cluster called CRM. It has 4 microservices in this example: orders, shipping, users, and accounts, which may be the payment information, etc., of these users. So in this deployment architecture, we have mapped each of these microservices to a separate bucket. So this naturally limits the number of microservices you can have per cluster to 30. So if these are not very heavily utilized services, the cluster may not always end up fully utilized. But now, with scopes and collections, there is a new alternative available to you to map a collection to each microservice. So you would still create a bucket, since collections have to be created inside a bucket. So let's say we call it the sales bucket. And then inside that bucket, we have created 4 collections here. And we have mapped each of these microservices to a collection. This way, we can have up to 1,000 microservices per cluster. So, if this application has a lot of microservices, you can consolidate them all in one cluster. So microservices provide access isolation, namespace isolation, lifecycle management. However, they do not provide resource isolation. So, collections do not provide resource isolation, I should say. So the boundary for resource isolation is still a bucket. So if it turns out that in your architecture, some of the microservices are more heavily utilized than the others. So let's say orders and shipping are more heavily utilized than users and accounts microservices, which have more intermittent activity. You may want to create a separate bucket for the orders and shipping application. Let's say it's called sales, and another bucket for the users and accounts collections, say it's called customers. That way you can give more resources to the sales bucket. So because you can control the RAM allocation, the IO priority, the disk queue attach at the bucket level. So this way, by combining buckets and collections, you can have both resource isolation as well as scale for your microservices. Okay, so now let's switch gears to managing SaaS applications. SaaS is just another term for multi-tenant applications, which are offered as software as a service. Multi-tenancy is usually a toolkit approach, and that is how we at Couchbase view it as well. We offer you various choices for your multi-tenant architecture, and there is a trade-off between total cost of ownership, TCO, and isolation. So if you want more isolation, you would go with something like clusters, but it increases your TCOs. We offer now scopes as a third alternative to your various multi-tenancy options with sufficient tenant isolation for many cases, most cases, I should say, but with higher multi-tenancy scale. And you may follow different approach even within the same application for different customers. So if you have some really huge customers, you may give them a separate cluster. Whereas if you have a lot of smaller customers or trial customers, you may go with the approach which is more cost-effective but doesn't need full resource isolation, and hence map each of these trial users to trial customers to a scope. So it's basically, like I said, a toolkit approach, and what we provide you is various options for mapping your application during deployment. So this slide just shows a sort of summary view of the different approaches you can take to multi-tenancy in Couchbase, and how the different isolation dimensions stack up with each of these approaches. So, if you put each tenant on a separate cluster, naturally you get a very high resource isolation level and physical isolation as well, but your TCO is high. On the other end of the spectrum is just doing everything in the application and nothing at all in the data layer. So in this, you get absolutely no isolation if you use typed key prefix within a single bucket. So that's the last row here. Between these two extremes are more, scalable alternatives with reasonably sufficient isolation. You could use a separate bucket per tenant. So in this case, you can pack up to 30 tenants per cluster. You still get some resource isolation because, like I said, you can control RAM allocation, IO priority at bucket level. Your TCO is lower than having a separate cluster. But again, you're limited to around 30 tenants per cluster. Whereas if you map a tenant to a separate scope, you can go up to 1,000 tenants per cluster. So your TCO is much lower than the other alternatives. However, you do not get resource isolation, but you do get security isolation through our back control, and you do get namespace isolation. And we'll see in the following example how that can work really well in many cases. So let's go back to our CRM application example that had, orders, shipping, users, and accounts microservices, which were each mapped to a collection. Now, let's say your application is very successful and you want to start offering it as a SaaS service to others. So to keep your costs down, you want to now convert your architecture to a multi-tenant architecture. And what you want to do here is at the data layer, essentially map each tenant to a scope. So thus far, we were not using the scope level, but now we use the scope level to map a tenant. So as you can see, we have created the same collections within each of these scopes. So tenant 1 has orders and shipping, tenant 2 has orders and shipping. And this is not a problem because the namespace within each scope is independent. So, there's no collision here. Same thing, the 2 orders collections can have documents with the same key. And the same thing is going on here with the other 2 microservices, users and accounts. Each of these collections gets created in the scopes assigned to each of the tenants. So this is how, your data model looks at the data layer if you're using scopes as your tenant boundary. So in terms of the application code at the SDK, this is a guideline for how you can make it tenant agnostic. Basically, this is a Java snippet, which shows that this is just usual stuff you would do in Couchbase. You would get a cluster handle, you get a bucket handle. So in this case, my bucket is, let's say, called customers. I'm doing something with the customers bucket. I want to basically, let's say in this example, insert a new user. So I get a handle to my customer bucket. So when I'm writing my application for the scope handle, I would parameterize it to take a tenant parameter because I want to be able to use the same code for different scopes depending on who the tenant is. And then once I get my collection handle to users, I can insert a JSON object to add a new user to the user's collection. And then I can even use the query language Nickel. So this is a simple statement in Nickel to select everything from the user's collection on the scope object. So scope.query. So now if I'm just running this on my single tenant version, which we looked at first without creating scopes explicitly, I would basically pass in the tenant as default, and then it would just go to the default scope. Now, if I want to access the user's collection for tenant 1, I would just pass tenant as tenant 1. If I want to access it for tenant 2, I would just pass the tenant parameter as tenant 2. So the same code works for different tenants seamlessly. So with that, I would like to wrap up by summarizing what we've talked about in this session today. We talked about application development and deployment patterns with scopes and collections. So first, we looked at how you can model when migrating an RDBMS application. Next, we talked about how you can model when deploying a microservices-based application. And thirdly, we looked at how you can model when deploying a multi-tenant software as a service application. What I do want to emphasize is that these three are not independent of each other. So the patterns we talk about work if you're doing all these three activities together. So it's not either or. So, let's say you're embarking on modernizing your RDBMS application. At the same time, you're replatforming it to use microservices, and it is a multi-tenant application. So you have patterns available to you to do all these three at the same time using scopes and collections and buckets. Thank you very much for joining this session. Please feel free to type questions in the chat. I'm available to answer them. Thank you.